Hi everyone, welcome to the channel. I hope you are doing great today. In this video, we are diving into something truly exciting and honestly very different from the usual AI demos you see online. What happens when you take AI out of a website and drop it into the real factory or warehouse? Can it understand safety rules there? Can it detect hazards? Can it watch real CCTV footage and make the right decision? That's exactly what this new research benchmark called FieldWorkArena tries to answer. And don't worry, I'll explain this entire paper in the simplest words possible so anyone can understand it, even if you have never read an AI research paper before. So let's get started. So here, this is the paper, FieldWorkArena Agentic AI Benchmarks for Real Fieldwork, and it's published in 2025. So let's understand this paper by abstract, what this abstract says. So here in their abstract, this paper presents FieldWorkArena. It's a benchmark that tests AI agents in real physical workspaces like factories and warehouses. Because most AI benchmark test computer tasks, but real factories need agents that can understand their manuals, watch camera videos, detect safety issues, report problems. So this benchmark includes real factory and warehouse videos, real manuals and safety documents, more than 400 real tasks, and the new scoring system that gives partial credit when the answer is close but not perfect. And the result shows that the agents like GPT-4o can be evaluated with this benchmark, but they still fail at many real world tasks. So here they are telling that this FieldWorkArena is targeting real world field work. And also they are sharing that existing benchmarks have been limited to evaluating web tasks and are insufficient for evaluating agents in real world environment where complexity increases significantly. So here they showed that they have proposed a system where it shall be able to work in real environment, and this data set consists of videos captured on site and documents actually used in factories and warehouses, and tasks were created based on interviews with on-site workers and managers. And also they have discussed that their complete data set is available at this place. Now let's understand their introduction now. So here in this introduction, the authors explain why they built this benchmark. So we know that AI is being used in factories and warehouses, and these places need AI that can follow safety rules, analyze CCTV footage, report violations, understand workflow. But current benchmark only tests online tasks, not real world physical tasks. And these real workplaces are noisy, confusing, full of movement, and have strict safety requirements. So, this FieldWorkArena fills this gap by providing real recordings, real rules, real safety manuals, and real problems to solve. So, this let us try how well agents can work in actual industry environment. That's what they have shown, that in manufacturing, logistic, and other fields, there is a growing need to address labor shortage, improve productivity, and enhance efficiency. And then they have said that technical challenges includes addressing diverse and multi-stage tasks and adapting to complex and dynamic on-site environments. Also, they have told that they are proposing an agentic AI benchmark that aimed at promoting the introduction of agentic AI. And these data sets include more than 40 types of data, video, work manuals, and approximately 400 field space queries, as well as the ground truth manually annotated by them. Also, they have told that by defining the functions, the system can comprehensively handle various types of online tasks, which enables users to train existing agentic AI under development as well as qualitative evaluation and comparison. Next comes this field work arena data collection. So now this paper explains how they collected the data. So here they comes with the input data acquisition. So here they collected videos from 11 factories in 11 cameras which are installed in communication equipment manufacturing factory, and also they have extracted it videos from this 8 cameras in warehouses. They also collected real manuals, safety guidelines, workflow documents, and they blurred all faces for privacy. So this factory data includes tasks like cleaning, shoulder paste, assembly, and safety checks. And warehouse data includes receiving goods, sorting items, and forklift safety. So that's what they have told that this factory one. So these 16 types of videos were divided into videos ranging from several seconds to several minutes. They have discussed the two types of documents were made there, and then they have shared that next data was warehouse data. So where they have 8 fixed position cameras installed in warehouse that handles electronic devices. Also they shared that how the data will look like, and since documentations could not be obtained directly, so they have modified the manuals related to journal warehouse operations. Next comes their query generation. So here in this one, all the tasks in this benchmark are based on real safety needs. That is, the team asked actual supervisor questions like, what do you want AI to detect? What mistakes cause accidents? What rules are most important? And from this, they created tasks such as detecting missing PPE, spotting safety violations, measuring distances, checking workflow steps. And each task has difficulty level, clear rules, video or image reference, number of expected steps called oracle actions, which tells how hard the task is. So that's what they have told, that we have made sure that the tasks match the actual needs of the workplace. Also, they discuss about oracle actions, which means the average number of minimum number of action spaces required to perform the task. And regarding the input images, they told that they reviews the captured data and extract the appropriate sections. Then comes this annotations. Now in this annotation, for every task, they create correct answers called ground truth. And one annotator writes the task, two other annotators check it, and everything is verified for accuracy. So they annotate yes no answers, distances, time durations, violation status, summaries, object counts, which ensures fairness when scoring AI agents. That is, they are saying that the ground truth can be logical values, qualitative numerical values, or strings. So they have calculated the numerical values such as speed or distance, values that are based on the size of the objects that humans can use as reference. Additionally, the execution log of the report is set as correct answer format. And the correct answer data is currently not open to public because they have prepared for the future work competitions. Then comes their benchmarking and evaluation methodology. So this section explains how the benchmark works. So here, first we are having a definition of action space. This is extremely important. So here, this fieldwork arena gives the agent a set of tools it can use. Just like a real AI assistant in factory would. So these tools are grouped into 3 parts. The planning tool, which can read documents, extract workflows, understand manuals. Perception tools, which can detect the objects, detect PPE, track workers, measure distance, measure time, recognize actions, count objects, compare text, extract frames. Then this action tools, which validate the safety rules, create incident reports, send reports to the system like ServiceNow. So agents must choose the right tool in the right order to complete each task. So here they have told that we have defined an agent action space to ensure a rich set of perception analysis and manipulation tools. And they have shown that all these things are detailed in table 2. So this is the table 1 and this is the table 2, where they have told that group 1 is the planning, group 2 is the perception, group 3 is the action here. So they have discussed all the tools that they have used. Then comes their task. So here the tasks are grouped into 4 categories. That is the planning. And here in this planning, these tasks test understanding of documents of workflow. For example, extract steps from manual, list instruction from video, summarize a procedure. That's what they are telling, planning, perception, action. So in the planning, it represents a central function of agent. So it includes understanding the task to be performed and extracting the workflows. That is reading and understanding the workflows that they are telling. And then comes this perception here. So this perception, these test the agent's virtual understanding. For example, detecting missing PPE, check if the worker entered a danger zone, measure distance between worker and machine, count unsafe actions in video. So that's what they are saying. The perception includes incident violation detection, special understanding, workflow integration. Next comes this action. So here this action tests whether the agent can make decision and report incidents. For example, identify violation, generate correct reports, fill out safety forms, send notification. So that's what they are saying, that it determines whether to provide feedback to humans based on events detected by planning perception. So specific examples that they told, that it identifies events that should be reported as near misses based on this planning perception. Then comes this combination task. And these are the hardest, because here the agents must read rules, watch videos, detect issues, decide violation, write a report. And this simulates a real safety assistant. That's what they're talking about, that all these actions, so combination tasks are defined as tasks that combine group 1, 2, and 3 and have large number of action spaces required to execute individual tasks. Then comes the evaluation environment. So here this fieldwork arena, it works on browser gym. This is the browser gym, which allows agents to interact step by step. So here in each step, the agent sees something, it chooses an action, the environment returns a result, and everything is logged. And this allows detailed evaluation. So here the responses are provided in chat format, and then as output as ServiceNow instances that they have told. And by executing this, they can have the output logs. Then comes the evaluation method, right? So here, unlike simple benchmarks that uses more detailed scoring, it has correct. That is exactly right. Partial correct is close enough, and incorrect is wrong. So partial credit matters because real world answers are not always black and white. Numerical answers are scored by closeness. Text answers are compared using similarity. That's what they have said. So the fieldwork arena judge results are set to three types: correct, incorrect, and partially correct. So for partial correct, a value corresponding to degree of agreement with correct answer is assigned, like fuzzy match they have used. And then they're having a final accuracy rate is calculated as average of each score. So the correctness score and the numerical scores is 1 for correct or partially correct and 0 for incorrect. And then they have defined this formulas there. And then they are having a final score using this formula. And then comes their experiments part. So here this section explains how these tested the benchmark. Okay, so this one experiments part. So they tested this GPT, 4 Mini, Gemini, Claude, and all. Okay, so videos were processed by taking up to 30 frames per second. Let me just take another marker, as something is already marked there. Okay, fine. Uh, so here we'll discuss this experiment section. Let me come to experiments part. Yeah. So here videos were processed by taking up to 30 frames per video, because current models cannot read long raw video directly and the timestamps were added manually. That is, they have told that they have taken it up to the maximum of 30 frames and were used as input, because some of the tasks require the participant to respond to time information. Then comes their results. So here this GPT-4o performed task. So the scores were that they have discussed the number of tasks. Table 3. This is the table 3. So here they have discussed that planning task is 0.39, okay, perception 0.46, action 0.25, combination task 0.20, total is 0.315. And this numbers shows that text tasks are easier, visual tasks are harder, multi-step tasks are the hardest. And this real world performance is far from perfect. Then comes their discussion here. So, here in their discussion, this section explains why models struggle. So, they are discussing about this fuzzy match function and the tendency of this LLM inference. The problems is that fuzzy matching sometimes marks hallucinations as correct. PPE detection is decent, but distance measurement is poor. Counting action is difficult. Reporting tasks need long memory. Combination tasks overload the models. So the conclusion is that current models are not ready for real world field deployment. So here they have told that this is the weak point of LLM named hallucination. Also, they found the correct answers were considered strictly match and other fuzzy matches. Then tendency, they have shared this one combination task that MLMs do not provide a function that allows them to answer a rough query to task by breaking it down into appropriate subtasks. This way. Then comes their related work. So here in this related work, the section compares FieldWorkArena with other research. So first, they are talking about this multimodal LLMs. So these are the models that understand images and text, but they still cannot reliably estimate the distance, understand the 3D space, track time or action, reason about safety rules. So, however, these approaches utilize 2D images, limiting their ability to perceive 3D space, crucial capabilities. This way, they are telling. Then comes this LLM agents for Edge AI. So here they tell that these agents needs to work in factories, warehouses, on-site servers. But large models are too slow and small models may be needed. So that's what they are saying that we have talked about two approaches for deploying lightweight LLMS fieldwork, sport agentic AI, prompt engineering, fine tuning. So this way. Then comes this benchmark suite for agentic AI. So this current benchmark only tests web tasks, digital tasks, simple images. None test PPE, hazards, distances, multi step workflows, real safety rules. This is why Fieldwork Arena is unique. So, they have told that their agent has been proposed as a benchmark for automating machine learning experiments which perform various actions for experiments, such as reading, writing files, executing codes, and interpreting the results. Okay, so then comes their contribution here. So here in this contribution, at this current benchmark, only test, this contribution. So this contributes four important things. So here they say that we propose the only standard benchmark constructed for evaluating the performance of agentic AI, which enables continuous research. Okay, so this paper contributes four important things. First, benchmark for real field tasks, clear action space for planning, perception, action, new evaluation with partial credit, and results on real models like GPT. So they have proposed new metrics. They have defined the action space. So they have demonstrated the validity. Then comes this conclusion and this future work. So this paper ends with a very clear message. That this fieldwork arena helps test how well AI agents work in real industry environment. So the future improvements may include more task types, more industries, longer videos, better evaluation matrices, stronger real world planning tasks, and this benchmark is public so others can build on it. So they have told that future work includes improving the evaluation index, adding tasks on scenes other than manufacturing, distribution, enhancing the benchmark functions, and others can also use it as they have shared this data set. As the complete data set and evaluation programs can be downloaded from this website. I hope now you can understand this paper in a better way. Thank you.